us. For those of you that are new joining us this morning, the Tech Council is a statewide trade association focused on technology-based companies. We do public policy on behalf of our industry. So yes, we've been busy the last few months. Before COVID, we did about 160 events throughout the year. In the last 7 months, we've done quite a few. We will continue to do virtual events, but we are now moving into in-person events as well. We have a number of publications, and we also work with our members to negotiate lower cost products and services for them. We offer health insurance and 401k programs, and shortly we'll have new information about opportunities for professional development and post-secondary education. But it is my pleasure to welcome you all this morning to the virtual Tucson Tech Talk series. Today's event is on trends in robotics and automation. We ask that you please remember to keep your microphones muted and your cameras off. We want to ensure that the focus remains on our panelists and on our moderator. For today's event, please make sure to put all your questions in the chat area, and our moderator will compile and pull the questions from there at the end in the QA session. Currently, we have sponsorships available for future speaker series events and all future Arizona Technology Council events. For all of those events, please be sure to visit our website at www.aztechcouncil.org, or make sure to email myself or Jamie, and that information will be available on the chat as well. If you're interested in becoming more involved with the Tech Council, please be sure to reach out to us as well. We currently have many opportunities for committees that are looking for members. Again, feel free to reach out to me or Jamie for that information. And at this moment, it is my pleasure to introduce you, our moderator for this morning. Mr. Brett Dooley is a mechanical engineer with Imposition Technologies. He collaborates with business owners and engineers to develop targeted solutions for motion control and automation challenges. He uses his wide experience in business development, industrial repair, and a decade as an electronics tech in the U.S. Navy submarine force to ensure delivery of an effective, robust automation system. Brett, thank you so much for being here this morning, and the floor is yours.
All right, good morning, everyone. I'm glad you could join us, even though we have a little bit of a storm this morning. So I'm glad everyone's internet was still working. I want to get right into it because we've got a lot to go over. So I'm going to introduce each of our panelists and give them a minute or two to talk about their company and themselves. And then we are going to get started with some questions. All right, so to start off, I'd like to introduce Michael Heelan. He's a senior automation engineer at Yamaha Intelligent Machinery and Factory Automation. Michael Heelan is a graduate of Jacksonville State University in Alabama with an undergraduate double major in applied electronics engineering and applied manufacturing engineering with a master's degree in manufacturing systems technology with a specialization in automated production systems. He has worked in university education after graduate school, teaching courses in robotics, PLCs, machining, engineering materials, and performing research work for the Department of Transportation. Michael has diverse experience in manufacturing automation, working in custom machine design and robotic system integration. He has experience developing vision-guided robotic systems, quality inspection systems, full assembly line integration, and engineering. He has assisted customers in the aerospace, government, automotive, and general manufacturing areas with control system integration and industrial robotics. Michael joined Yamaha Intelligent Machinery in 2021 as a senior automation engineer, supporting sales and engineering across the USA. Yamaha has a diverse line of robotic arms from SCARA, articulated, single-axis and multi-axis Cartesian robots. Michael supports pre- and post-sales across the USA and provides engineering support services to Yamaha's customers in the robotics space. It is his goal to provide excellent automation support to Yamaha's customers and to expand the Yamaha brand across the USA. All right, Michael.
Hi, everybody. So I'm with Yamaha. We have a diverse line of robotics, mainly in SCARA and Cartesian robots, and then we have a lot of single-axis robots and linear robots that we use to support our customers. We're growing our business here across the USA. We're relatively new setting up our office to support USA customers here. Most of our offices have been in Japan and Europe in the past, so we're just getting rolling on that. We do a lot of work with our distributors around the country to support customer projects. And if you are ever working on a Yamaha robot, feel free to contact us directly as well for support. And we're doing advanced work in new robots coming out. We're developing a cobot, and we're doing a lot with agricultural farming systems as well. It's a new area we're moving into.
Great. Well, thank you very much and welcome. All right, next, I'd like to introduce Samuel Bouchard. He's the co-founder and CEO of Robotics. Samuel co-founded the company to free human hands from repetitive tasks so workers in factories can do more. Robotics builds applications for collaborative robots that are used by tens of thousands of manufacturers worldwide. He's also the author of Lean Robotics, a guide to making robots work in your factory, and I've read it, and it's a great book. Samuel?
Thanks for the intro, Brett. So our customers are manufacturers, and as all of you in the industry know, they get it. They know they need to automate. They need to deploy robots. The challenge is sometimes it's too complicated. So what we try to do with the products we build is make it easier to deploy. So we have plug and play components and configurable applications, so you can deploy cobots in your factory. So we try to make it easy to use, easy to deploy. And we also work with a network of local partners throughout the world, and Brett working with IP Tech, which is one of them in your specific area.
Okay, great. Thank you very much. And finally, we have Tony Rigoni, Director of Industrial Markets at Quanergy Systems. Tony works with top customers and technology partners to develop innovative solutions for the manufacturing, logistics, and warehousing, port automation, transportation, mining, and other industrial segments. Before Quanergy, Tony has 25 plus years of experience in the industrial automation space, driving customer design solutions. He's an expert in sensors, motion, robotics, safety, PLC, DCS controls, and SCADA systems from the edge to the cloud. Most recently, he was the GTM Senior Manager for Cisco Systems, Internet of Things Solutions Group, where he successfully helped launch several IoT solutions. Tony holds a Bachelor's of Science degree from the University of Southern California. He currently resides in the Bay Area, where he spends his free time participating in several outdoor recreational activities, coaching youth sports, and spending quality time with his family. All right, Tony.
Thank you very much, Brett. Thank you, everyone, for joining us today. Love to talk to you more. Quanergy, yes, we're probably the new name on the block here. We've been around for about 10 years now. We are a Silicon Valley startup back then, really around the self-driving car. How do we give perception and vision to self-driving cars using LiDAR? So we've taken this technology, and basically now we're bringing it to the industrial market, and especially in particular to robotics and stuff. Robots are great, and the other guys are going to talk about it today. But really, it's about how do we perceive and give the robots more intelligence about what's going around them. And that's where LiDAR really does come in. And some of the latest state-of-the-art technology is really helping us promote that manufacturing and industrial environments. Thank you, guys.
All right, thank you very much. Okay, so we've introduced the panel. Now you know everyone. I would like to ask kind of an initial question to everyone, and we'll just keep it in the same order. For the responses, Yamaha, Robotics, and then Quanergy. I would just like to hear what is the most interesting technology you've seen come out recently, and also what do you anticipate might be your answer to that same question in 5 or 10 years? What interesting things do you see coming in the future? Okay, Michael, what do you think?
The area of biggest growth I've seen really in the past 5 years is the use of mobile robotics in automated warehouses and manufacturing. That will incorporate machine vision and LiDAR sensors to self-navigate around a facility. They're coming out with new brands and new types all the time. Now you can get mobile robots that have an industrial arm on them that can do picking and placing. There are also larger systems that can carry pallet-sized objects around a factory, and then also small kitting robots that aren't really there to replace people, but to make them work more efficiently in a warehouse. So there's a lot of new avenues coming out in mobile robotics, and I expect that to grow even more and outside of the factory as well over the next 5 to 10 years. Thank you.
Awesome, thank you. Sam, what about you? What have you seen?
Yeah, I've seen some new tech, but I'll be a little bit boring. And I know it's a tech council, but what I've seen really is obviously there's always new tech, but what's exciting now is really more the adoption of tech. That's really what's exciting. So there's always been that labor challenge that everybody experienced, but it seems like the last year in the pandemic kind of did that step function. And now there are even more reasons to automate, and people are adopting it ever faster. And I think it's going to continue like this. What we need to keep working on as an industry is really improve that price performance ratio, where it's going to make more sense to use it. And yes, there's going to be that performance. So having robots that are more flexible, so more sensors on the vision side, on the tactile side, also combining this with the decision making of the robot, but also believe in terms of the ease of use, there's gonna be some innovation on that front. So it's not the capability of the system themselves, but make them really easy will make a huge difference in terms of adapting it. So I think if we sit here in 5 years from now, we're going to see robot systems that do much more, that really have more sensory motor skills like we have, like we humans have. So combining senses and the dexterity, but also believe that they're going to be much more easier to understand for people. So they're going to speak the language of the user, and the user won't need to learn the language of the robot. A little bit like we saw with the evolution of computers. So I don't know, for you, my first computer was a Commodore. I needed to learn the language of the computer to make it work. But today, my iPhone understands my language. When I take it out of my pocket, it understands what I mean. So I believe in terms of human interface with machines, we're going to see a lot of innovation as well.
That's great. And I know what you're talking about. I think everybody in the chat or in the group here might have remembered programming in BASIC at some point in their life. And everything's made a giant step forward there. So that's great. Tony, what about you?
Yeah, it's similar to both the other guys, Michael and Sam both said. We're seeing there's huge growth in mobile robotics and basically robots to be more autonomous, more self-driving themselves and stuff. We're seeing the trend we're really seeing is basically everything that's traditionally been much more base sensory or 2D sensing. We're really moving towards much more 3D or true perception of around the vehicle in these robots. And that's what they're all looking for and what the future is, because today they're still limited on their functionality in a very set environment. But by giving them more of that sensory input and giving them that perception, three-dimensional perception, they're able now to navigate, do things on their own. So we're really seeing that trend coming today. You asked for 5 years in the future. The big thing I see today is everyone, that's great, but the cost is way too expensive. And that's been very prohibitive to allow these robots into these places from a price performance ratio. We're seeing the trend really shoot down. There's the latest innovation, especially in the LiDAR sector, is basically going everything to solid state technology. So you're basically taking all this technology we did before in a very expensive laser mechanical setup and moving it to silicon, which will greatly reduce the cost of sensing. And in the future, I see the day, sensors are, instead of $100,000, $50,000, $10,000 sensors now, you're getting down to $100 sensors, even sub less than that. Using that LiDAR, giving robots greater perception of their environment and allowing them to be autonomous.
Awesome. No, that's great. Did anybody have anything else you wanted to add after hearing what everyone else said? Nothing? Okay, great. So I have a couple of questions that I'm going to ask each of you. And once again, I'm just going to kind of keep the order the same. Hopefully everybody's happy with their place in line. But so Michael, I wanted to ask you, Yamaha has quite an extensive suite of vision capabilities inside your capabilities. So I think this would be a good question for you. How is the integration of machine vision and computer vision really changing the industrial robot space?
Thank you. So the integration of machine vision and computer vision with robotics is really changing the game and what is available and what you can do with robots. It provides the ability to inspect products, and it also provides ability to give alignment and path guidance for the robot in the work cell. And that's even expanding even more with things like NVIDIA's graphic engine, where a camera on the end effector of a robot can actually sense all the objects in the work cell and identify them to find the specific place it's supposed to be performing the work. It's allowing a lot more flexibility for inspection systems. Computer vision is often used with robot guidance, assembly operations, gluing operations, welding operations, and pick and place operations. And this has really been growing in 3D bin picking as well is something that's really starting to take off, where 5 years ago it took a special system, custom engineered, and now you can do a lot of that right off the box without much programming background to get the robot to perform the job that you need it to. And machine vision is opening up a new world of technology applications of what can be achieved with industrial robotic systems, improving both quality and the efficiency of the systems. Also, with AI integrated vision systems, you can perform vision inspection on large field objects and complex objects where vision systems in the past that are rules-based would be almost impossible to program those systems. So I was looking at inspecting strawberries and apples with machine vision and how you could use a robot to pick out the bad fruit, but you can do it en masse. So it's really opening up a whole new world of what's available and the flexibility that it's allowing the robots to operate with. Thank you.
You mentioned cameras on the end of the robots. Sam, that made me think of Robotics product offerings. Do you have anything to add for this question on how machine vision has been affecting the use of robotics?
Yeah, so why we did this camera after doing 4 sensors and grippers is we realized that sometimes doing the job was not the issue with the robot. It was actually getting to the part and finding the part. So it was really allowing for more flexibility. And just like Tony was talking about, going from the mechanical space to more the solid state is the same idea in manufacturing. How can we go away from fixed jig, mechanical jig, and give more flexibility to the system so it can adapt, because there's always be some changes on the factory floor. It's going to be change in production, change in products, etc. So how can we bring this adaptation more on the software side without having to do custom mechanical parts all the time?
Got it. Tony, what do you have anything to add on this discussion using machine vision? I mean, that's really the focus of your company is a form of vision. So
it's a form of perception. We're seeing a lot of every sensing technology has its advantages and disadvantages. So where we're seeing is a lot of places to supplement machine vision today, traditional machine vision. Machine vision is fantastic under controlled lighting conditions where you get to some areas where outside lighting, outdoor manipulations like that, it's where LiDAR really starts to shine, or longer ranges when you want to start scanning stuff, at 100 meters out, those kinds of things. That's where we really do see the advantage there. But it goes back to the more information, the more sensory input we see to any of the robotics. It's just like a human being. We have eyes, we have ears, we have hands. The more sensory input we can give to the robotics, the more we can let them collaborate with humans, the more we can get them to do autonomous tasks and stuff. So
quick question to follow up on that, just on the off chance that we have some people who don't know the answer to this already. Would you mind just giving a very brief overview of what LiDAR means?
Sure, no problem. So what LiDAR is basically is light detection and ranging. So if you want to think about it, radar does the same thing, shoots radio waves, bounces off a target and comes back. We do the same thing with light. We shoot off a target, a laser beam, it bounces off of it, returns it. We measure the time it takes for that. Light is a fixed constant, 187,000 miles per second. So we measure that time it takes, and then we know that distance. We take something like that, and there's like a product here, like a LiDAR sensor. We spin it 360 degrees. We can now take a 360-degree map, use multiple lasers, and now you can do a 3-dimensional map around it. So with a single sensor, you can get basically a profile of everything around in your environment. So that's what we're doing, and we call that the point cloud that we generate.
Okay, and Michael, would you be able to give us just a quick overview of what you mean by machine vision in a more conventional sense? Would that be possible?
Sure. So machine vision is going to be using like a CMOS or CCD sensor, and it'd be a video camera image or a still image. But then on top of that, you have a tool suite where you can inspect, you can take that image and then you can draw lines and shapes across that with tools that will inspect different features within that image. And then also you can do things like read barcodes, read optical character recognition, things of that nature. So it allows you to use tools on top of an image interface.
Awesome. Yeah. So there's definitely places where one technology is more appropriate versus another, and that's kind of where you guys come in and help people find the solutions, I would assume. Yeah. Awesome. I am going to switch gears just a little bit away from vision now. Sam, I was hoping to pick your brain here on how you feel collaborative robots are influencing the manufacturing process. And I want to preface this a little bit, kind of the same as the vision. If you wouldn't mind just giving us a brief overview of what you mean by collaborative robots, that would probably be helpful.
Sure. So everybody's probably familiar with industrial robots. So we've all seen those ads of cars being manufactured, those big arms and sparks flying around. So that's really the industrial robot. So it's armed that do any kind of job on the manufacturing floor. It can be welding, packaging, putting boxes on pallets, etc. So collaborative robots is a subset of this. It's the same thing. It's an arm that will do a manufacturing task, but there are two things that will really differentiate them from their industrial counterpart. First of all, they're limited in the force they can apply and in the speed they can go at, which means they can coexist with humans. So it requires less change in the layout when you deploy them. That's the first thing. And the second thing is really their ease of deployment. So ease of just installing because you use a regular outlet, ease of designing the system because they can be built with different plug and play components, ease of programming because their interface is easier. So that ease of use, what it does is it really changed the economics of deploying a robot. While industrial robots, usually they are very high performance, but they require probably bigger engineering projects to be deployed. Cobots, they might have lower performance, but the cost of deployment will be much lower. So if you need a lot of flexibility, cobots are great because for a smaller cost, because the cost of integration is smaller, you can deploy them, have a good ROI, and adapt as your production change. So that's the difference between the cobot and the more traditional industrial robots. And how we're seeing our customers, again, they're manufacturers. Some are very small shops. So it's 3 guys, a CNC and a robot. Some are global 500 manufacturing companies. So for the smaller user, it's really that ease of use that really makes a big difference. It makes it accessible for them to get into robotics and use it. And for the bigger manufacturer, usually they already use industrial robots, but they will use cobots in new use cases. So where the space constraint is more, the space is tighter, so you cannot put a lot of fencing, etc. So that's one use case. And also, again, that flexibility. So we have a lot of part manufacture in various industries, so automotive, aerospace, general industry. And they're really, that flexibility is very important. So they cannot program it and let it run for years and years. They're going to have new changeovers all the time. So that ease of programming, that low cost of deployment, but also low cost of adapting and low cost of changeover really makes it compelling for them.
So, I remember a rule of thumb, used to be, if you're not going to make thousands of something, there's no point in automating it, years ago. Would you say that number has come down significantly using that technology? And do you kind of have a ballpark number you look for that you could tell people, hey, 50 or 100?
Yeah.
Have you seen anything like that?
I don't have that number ballpark,
Sure.
but what I can say, and maybe Brett and Michael, you can complement that answer. A typical cobot project or a small cobot project can be in the low 100Ks, and maybe a project when you get a system integration and you have a high performance cell, it's probably more in the 250K range. So there are rooms for these two kind of solutions, and if you have 100K something or 150K solution, then when you look at your ROI, and then the ROI calculation is going to depend. That's why it's hard for me to throw a number in terms of number of parts that you make, but that gives you an idea of in terms of what kind of return, what kind of pace, and also there are some new reasons why people automate today. So at some point it was reducing the cost, but today it's I hear a lot of manufacturers, they don't have enough people to build their parts, and they're losing business because they don't have manufacturing capability. So the ROI calculation change. It's not about reducing the labor cost. It's about if I have that extra capacity, I can sell that more, and then the ROI calculation changes a lot.
Absolutely. And I was just talking to someone yesterday who said that they installed a robot, a collaborative robot, and they have had 0 load failures in the machine they were loading. And I was just curious because it seemed very simple, and I didn't think an operator would have trouble with what they're doing. But I just asked them, how many did you have when a person was doing it? And they said it was 1 a week. They would have an actual load failure that would break the process for a little bit. So I thought that was interesting that the robot was actually better at that particular very simple looking process than the human operator.
Yeah, and that's
Tony,
really the idea.
Oh,
yeah.
sorry, go ahead.
Yeah, sorry. I just said that's really the idea. So where can we use robots where robots are good? So doing the repetitive stuff, and where can we use humans at the things they're good? So where more dexterity is required, more judgment, more creativity.
Absolutely. And people like doing things that use their brain a little bit. Repetitive tasks can get boring very quickly. Tony, I was going to ask you if you had anything to add to this in the collaborative space.
In the cloud, we're just seeing to echo exactly what Sam said, we're seeing a demand for that more and more, the collab robots and stuff. Post-COVID world, it's been hard to get workers. It's hard to keep capacity up and all those things. So we're seeing the same thing across the board. And the biggest thing is how do we deploy all these robots? How do we navigate these robots? How do we get these things to start working in these environments? And but that trend is definitely there. Moving forward.
Got it. Michael, I think you said Yamaha was getting ready to launch a fleet of collaborative robots. Is that right?
So we have some type of collaborative robots in our farming applications right now that are actually attached to vehicles. Main one is for picking grapes from grapevines. And then additionally, we have our own cobot that's a standalone arm that should be coming out next year. It's in development. You can see a video of it on YouTube if anybody wants to look. So we're moving into that space. I would say the big difference between collaborative robots and traditional robots is the speed they can operate at. So if you have a very high speed process, that's more of a system that you would need that guarding on because the robot's moving too fast. Where a collaborative robot is meant to move at a speed where it's not going to injure somebody if it runs into it. And you have that force feedback. So that's the main difference a lot of times between those.
I'm going to follow up. I was going to hold the audience questions till the end, but since this is very topical to what you just said, someone asked us to talk about agricultural tech, how automation is there. How are collaborative robots or even traditional robots? You mentioned the grape picking. Can you give us some examples of places where you've seen the agricultural tech take off?
Sure. Yeah. So areas such as picking apples, picking oranges, picking strawberries and ground fruit and things like that as well. There's a lot of new companies that are startups that are working in the agricultural industry, and we focus on it a good bit because we're Japanese based, and Japan has 60% of their farmers retiring soon. And then there's not enough people that want to go into farming. So the solution for the Japanese is to have automation to do a lot of the labor work of the farmer. So we're seeing it grow more and more across the US as well. A lot of the technology is still in its early state and it will improve, but it is a growing industry.
So I've actually had an opportunity to look at a couple of agricultural projects, and it seems like one of the biggest issues in that is the machine vision side of things that you were talking about earlier. Would you agree that that's the biggest hurdle to the whole thing?
That's a big challenge, but with the adaptation of artificial intelligence algorithms with the machine vision, it's making inspecting what would be a good fruit to a bad fruit a lot easier than it would with a traditional based rule-based vision system, because you have different sizes of fruit, different shapes, and it all might still be good fruit. But with a rule-based vision system, you would have a hard time determining that everyone's a good thing. Where AI, you can teach it basically what good fruit looks like, and from that model, it will be able to interpret what other fruit is good or bad as you run it under the camera, if that makes sense.
It does, yeah. The idea of inspecting something that's organic is a totally different ballgame than looking at a machined part and comparing one to the next. Organics can be very difficult to look at. Tony or Sam, do you guys have anything to add in this discussion you'd like to?
Yeah, I would like. We're seeing a lot in ag. The challenge in ag is how do you get a vehicle to run all the time, 24/7 a day? And so we're getting actually a lot of requests. They want to automate these tractors, automate these fruit pickers, running, nonstop, bright sunlight to, dark at night. How do I see around that vehicle, and how do I also do safety around it? I can't have a farm worker walking on the site and getting run over by the tractor, the automated tractor. So we're seeing a lot of requests to basically protect the area zone around the tractors, and also to help with the general navigation of the tractor. So the tractor should be here. I see an obstacle. I see a farm truck, stop in front of it, go around it, those kinds of things. So and the key there is that's where LiDAR really starts shining. Is we don't care. It could be nighttime, daytime. It works the same. And so we can run 24/7 operations in ag. And we're getting a lot in profiling. So it's not just looking at things, but it's also basically giving you the measurements and profiling. So we can see how high the booms are on the tractors. We could see profile the crops and profile the shapes and look for the valleys and hills. So those are kind of applications we're seeing in the ag business. But it's all moving towards automation, and it's a challenge. I keep hearing from the farms, it's a challenge to get workers nowadays and stuff like that. More and more workers, and demand is ever increasing, but they have to automate.
Got it. Sam, anything else on that topic?
Nothing relevant to add on
Okay.
that topic, except that I shopped for a robotic lawnmower this week, and I decided not to buy it because of the navigation, because we needed to lay a wire. And I think that's kind of the next step. And
that's the whole point of LiDAR. Yeah. The old transition used to be, I call there, you had the wires, stickers on the ground, and with the next advent, I'll get into that in a second, probably, slam navigation and stuff like that is how we navigate.
It's really surprising to me that they're releasing a lawnmower with that technology, because that seems like it's like 2 decades ago. Like that's so far out of date now. That's crazy.
Yep. So
okay,
a few more years.
Absolutely. Well, I'm sure the cost of these sensors is driving that. It's hard to make a lawnmower that costs $100 grand and expect your average person to go out and buy one. Okay, so I'm going to keep on LiDAR for just another couple seconds here, Tony. So most people, I think of LiDAR, what you mentioned right off the bat, with self-driving cars, autonomous vehicles, things like that. But how is LiDAR useful in more of a factory or industrial environment?
So we're getting a lot of, it's very, great thing about LiDAR, it can be used in many different use cases and different applications, because we're covering such a large area and we're getting all that digital data back and building that profile. We can use it for many. So, we're getting applications, in the mining industry, in construction industry, a lot of volumetric measurements. I want to look at a stockpile. How big is it? How much gravel do I have in my truck? How much do I have in my scoop, bucket, and mining? We're seeing a lot, just outside that too, rail cars, rail safety. We've got several projects, tunnel safety for railways. Verifying rail tracks are basically nothing on the rail tracks. Good applications like there. In the factory environment, we're seeing quite a bit in basically the navigation space is huge. So for autonomous robots, the SLAM navigation, we call it simultaneous location and mapping. But that allows the bots to drive around the autonomous vehicles. But we're also seeing quite a bit in packaging. We can basically look at pallets, and we can look at boxes and give dimensions of them and give fill volumes. How much material is inside this box? We got a example, Amazon basically said if they could shave 1 inch per box, it'd be $100 million in shipping costs reduced. And so we're basically looking at, hey, let's see how much product we need there and build the boxes to the size that we need to build them. You need less stuffing, you need less stuff, it's less cost to ship it. There's a lot of applications around, counting, case packing. Anytime in the previous, you probably might have used like 10 sensors or something like that to analyze an area. With one LiDAR sensor now, it becomes a big area scanner. And we could build out how many parts are in this area. It's detect parts, detect the size, shape, distance, and all these good things. So that's where we're starting to see the increased demand into the factory automation environment.
Got it. So you mentioned building pallets and things like that. Sam, if I remember right, RobotiQ has a palletizing solution that's designed around the collaborative concept. Do you see that being more and more popular with industry right now?
Yes, definitely. Again, it starts with the labor challenges and the fact that some of these manufacturers sometimes, especially the ones who ship products maybe that are visible, let's say to the Costco's or the other shops like this, they need to change the presentation is important. And the cobot approach is interesting because it has limited impact on their layout. And again, it's flexible. So when they change boxes, when they change layouts, when they change queues, they can easily adapt. So we have a lot of interest and a lot of customers in the food industry. We also have some of the vaccine manufacturers who bought their system for that exact reason. They need to ramp up production, ramp up the palletizing. And so that ease of deployment was of the utmost important for them. So that's what we're seeing with that product that we released 6-7 months ago.
Great. It sounds like Tony and Sam, I need to get you guys in a room and we'll come up with some really cool stuff in the pallet space.
Yeah.
That's great. Michael, do you have anything to add on this concept? Machine vision plays a huge role in that, that we talked about the conventional Yamaha style machine vision plays a huge role in palletizing and packaging and things like that. Have you seen a lot of that, those applications?
Yes, that's quite common in industrial facilities and warehouse facilities. Either using an overhead camera to do palletizing or using an onboard on the tool camera as well works sometimes. Yep, so I've actually done an application for Toyota in the past where we were depalletizing engine heads off of a multi-level pallet with dividers in between. And that system really wouldn't have worked if we didn't have the vision system to guide in the robot. And it was on an overhead gantry reaching down. It was a FANUC robot. But with the vision system, we were able to achieve a cycle time that was faster than what we had quoted. And it ran faster than all the other robots in the line, even though it had a vision system. So there's a lot of flexibility with the vision system. A lot of it goes into how it's programmed as well. And it's somewhat of an art and somewhat of a science at the same time. But it adds a lot of advantages.
Great. Okay. Does anybody else have anything to add on this topic? Okay. One question that's come up a lot recently that I just wanted to ask everyone, and so I think Sam, I'll just start with you this time, is how you're seeing cybersecurity concerns impact decisions that are made in industry, factories, just across automation in general. Have you seen anything like that that you've had to deal with?
Yeah, well, we have a product where people can connect their robot to get just some performance data, so not any sensitive data. And obviously, the difference when you promote these products is that you don't only talk to the manufacturing people, but you talk to the IT people who are really sensitive to these cybersecurity. And we saw a lot of examples in the news that are really kind of marking the imagination of people and scaring a lot of businesses. But at the same time, it's clear for everybody that there's a lot of value in getting that information and optimizing it. So how I compare it is a little bit at some point in the history, everybody had their first website. And at some point, people realized, hey, the website is something that's critical to my business success. And then they started to analyze, optimize. And that's what we're going to see at some point with the manufacturing technology. And obviously, there are some early adopters and there are some people who will move. But it's kind of a trend it's clear everybody's going to get there. But obviously, there are some constraints and it has to be very robust. And there needs to be clear gain for the manufacturing people so they can work with their IT colleagues and say, okay, for the business, it is definitely worth investing in that direction.
Great. Tony, cybersecurity, any concern?
I could talk about from a previous life. I know quite about it, but basically the biggest challenge we see today in manufacturing is basically knowledge of what's out in the network. Traditional sensors, robots, and all that were never designed for security. They're designed for production. And the challenge is you start to get these business outcomes we need, these insights we need to start connecting all these equipment. As we connect it, a lot of it gets to the cloud, a lot of this data starts coming outwards. We've opened up now a threat vector. Robots themselves, all these security systems, cybersecurity stuff today, you plug in a printer, you plug in a laptop, it identifies, I know it's an HP printer, I know it's a Dell laptop that connected to my system. Once you plug in and there's a Rockwell PLC there or a FANUC robot or whatever it may be, it just says 10.10, 192.168.1. It has no idea what concept, what that item is. It does not know what a PLC is. It does not know what a robot is, all these things. So that is the biggest challenge we see out there. And that's why it's very hard for companies to set policies, automated policies around this. Like I said, traditional way has been to air gap these things to basically verify there's no connection. They have to do it now. People are starting to understand, we're starting to see cybersecurity attacks happen because manufacturing is the #1 hit cybersecurity area because it's not protected. And these devices don't have security policies on them. So I really view cybersecurity in industrial world very similar to I looked at safety about 30 years ago. It used to be, you go into a plant and they say, we haven't had an accident in years. Who cares? We don't need safety equipment. And then, they have an accident next day and they buy all the safety equipment. And now safety is the #1 important thing you go to any plant. Cybersecurity is going to be the same kind of transition going through it. People are going to have to start investing in cybersecurity, doing this because they have to do that to grow. If they want to be productive, they want the insights. They got to connect the stuff. They're going to have to protect the assets. So how to do it all? There's many different ways, and a lot of consultants out there doing that. So, but I see the future. Yeah, it's going to be more and more cybersecurity on there.
Okay, great. That's amazing information there. Michael, do you have anything to add?
Yeah, sure. So cybersecurity is becoming more paramount in a lot of industries. And before I was with Yamaha, I worked with Allied Electronics, going around to different facilities and helping them build their industrial networks and things like that. What I've seen a lot of is a lot of companies, while they spend a lot of money on physical security, such as gates and security guards, they don't really think of the cyber world so much, where they need to protect the inside of the factory as well. So that's costs more in employing managed switches, special firewalls, VPNs, things like that. A lot of companies have overlooked that in the past, but I think with the recent attacks on the Colonial Pipeline and JBS, they're becoming more aware of the dangers of not protecting the internal networks. And luckily, none of those attacks attack the operational technology of the system, the PLCs, the pumps, the valves, things like that. They just ransom the IT system. If a really sophisticated attacker got into your system and was able to get into the operational technology, they could actually damage machines, create bad parts, change PLC tag values, things like that. It's a more sophisticated attack, but it's becoming more likely as these bad actors get more sophisticated.
Got it. No, that's great information. Somebody asked in the chat if anybody knows the recent meatpacking plant breach was targeting the automation systems or not. And I don't know that off the top of my head. Does anybody know? Okay.
As far as I know, they haven't released any information that it has, but it could have possibly done that, and they just don't want to release the information.
Which is understandable from their standpoint. I have another question from the audience, and this is a great question. Sam, I'm going to direct this at you to start with. So it's about collaborative robotics, and what they're asking is if a smaller startup, or I guess it could be any company that's considered to have a smaller footprint right now, they don't currently have the funding for robotics. How would they go about systems engineering now with the intent of being as little disruptive as possible to future implementation of collaborative robotics in the future? So basically, they don't have the money for it now, but they also don't want to undo everything they're doing to install robots down the road. Do you have any thoughts on how a company might approach that?
So the question is, they don't want to buy it now, but they want to just plan like they will buy it at some point.
So yeah, I guess I didn't say it very well. So they're basically saying there's no funding right now for automation in robotics, but they also want to make sure that they are not making decisions that will make future implementation too difficult or more expensive.
Yeah. So I think this is true for any business, and for a startup business is you really need to master your manufacturing processes before implementing robotics. So if you're more doing artwork or craft work in the shop, and it's changing all the time, it's going to be difficult to implement robotics. At the same time, if you're a startup company, probably you should probably be optimizing for just building a product that your customer wants, and try to optimize the manufacturing at a later stage. That being said, we have some customers that they implement this right from the start. So I have two customers in mind. One is a glass manufacturer out of New York City, and they really they wanted to build their company from the ground up using robotics in their manufacturing because they couldn't afford having the manual labor. So these were the three guys, the CNC and the robot that I was talking in the introduction. And we also have some 3D printing company where they do some contract manufacturing of 3D printing, and that was part of their model. So they included the robotics aspect, so feeding and retrieving the parts from the 3D printer. It was part of their model, so it was right into their operating model and their financial model when they started the company. So these are examples on how you can use and leverage cobots even if you're a very small company.
And so when we're talking about places to use cobots, you can also use them for other things that people don't traditionally think of, like sanding, finishing, screw driving, assembly work. There's a lot of places that you can use them that may not be right off the top of people's head when they think about it. Is that right?
That's right. And then it's really what's counterintuitive there is that some things that are really easy for humans are not necessarily easy for robots, and vice versa. So again, everything that's sensory motor requires a little bit. So looking in my pocket, finding my keys is very easy for me. For a robot, it would be very difficult. But playing chess with 5 opponents is very easy for a computer, and it's very hard for me. So that's that trick there that yes, robots can do anything. But talk to people who know what are the possibilities of a robotic system and try to understand, okay, what is the gain and what is the complexity, and make sure that you find something. We always advise people to start simple, even though you would have an application that would maybe bring bigger result, have a bigger impact. You might be better to start with a simple application, get a success there, get a better understanding, build your knowledge, and then attack the high return, but also higher complexity. Because if not, the risk is that you can create a bad reputation for robotics inside your factory, and you kind of lose the opportunity to leverage that technology in the future. So that's why the start simple and keep it simple is an advice we repeat over and over again.
And your book targets that concept very well. If anybody wants to get more in depth on that, so I would look up Lean Robotics that Sam wrote. It's a very good overview of that process. Tony, I have a question for you. The mining industry is huge here in Tucson. It's very common. I was wondering how you're seeing LiDAR or any kind of navigation technology, if you want to talk about it, being used specifically in the mining industry.
So mining, the biggest areas we see is, just like step one is what we call ADAS, Advanced Driver Assistance Systems, basically giving the drivers of the vehicles a little bit more warning. I mean, you think about in your car, you drive back up, you get the beep, 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 you're about to hit something. We're attaching these LiDAR sensors to the vehicles themselves and basically giving them that warning that they might hit something, run over a car or something like that. Some of these vehicles are so large, those kinds of things. Step two to that is more to the autonomous, where they're actually able to navigate. They see the whole environment around them and able to drive around the roads and verify they don't hit anything or collide with anything, along with IMU and GPS data coming into them. Those are some use cases. We're seeing a lot, like I said, on volumetric measurement of the loads of the trucks, of stockpiles. Another key area is basically we're doing a lot in underground mining too, where we're actually verifying people's locations and safety. So is there anyone in this mine before they blast? Those kinds of things. Where are the vehicles? And as the vehicles travel underground, verify nothing's in front of them and they're going to make the pass. So it's greatly increasing. The other big areas, they're starting to move to all fully autonomous underground mining now. A lot of companies and the manufacturers. They don't want people down there in the mines when they're digging and stuff like that. So how does that vehicle run by itself underground? Today, it's a lot of remote control. They want to move from remote controls straight to autonomous. So those are the big areas we see quite a bit. And one area there that's a lot of interest is moving to the solid state, because traditionally mining's avoided LiDAR because of the mechanical components and the shock and vibe. But now the next generation solid state stuff, the stuff's bulletproof, so it can take the vibrations in harsh environments in those areas. So we're seeing increased adoption now of that newer LiDAR technology in mining.
Great. No, that's awesome. Does anybody else have anything they want to add there? Okay. Now we do have a little bit of time for more questions from the audience. If anybody would like to put one in the chat, so feel free to put that in. Otherwise, I am going to, basically, I would like to open it back up to, is there anything that we have not covered so far that any of you on the panel was really hoping that I would have asked you about? Is there anything that I've missed so far? I don't want to miss our opportunity here, so feel free to chime in if there is something. Okay.
Well,
So, oh, go ahead.
I guess the biggest thing was one of your questions, kind of what would happen over the next decade.
Sure.
We're going to see a tremendous change in the way robotics are going to be used over the next 10 years, as they're not just in factory applications, but you have driverless cars, you have driverless vehicles, drones, all types of autonomous machines. So I would say there's really a big transition happening in the industry right now.
Absolutely. And you know, speaking of that, you know, we brought up artificial intelligence a few times throughout this, but we never really spent any kind of significant time on it. Do any of you guys have any thoughts on, you know, the things that artificial intelligence is really doing on the cutting edge right now? What is surprising or new that you've seen people accomplishing with artificial intelligence? Does anybody have any thoughts on that? I don't want to call out names and throw somebody to the wolves, but if anybody has thought of anything.
I mean, from our side, we're using AI actually in some of our new detection algorithms. So it's not just about ability on 3D point cloud, it's what is that target, what is it? So we're able today to look at, is it a person, is it a car, is it a truck, is it a bicycle? And how is it going to move? And you know, what's its path now, what's its projected path? Those kinds of things to help help machinery and robots to basically navigate around it or to identify what they're looking at. Because you treat a rock a lot different than you treat a person or a car. So that's what the systems need to understand, better perception of what their environment is around them. And so AI is a big play of that. So,
Sam, did you have anything you wanted to add on this one?
Well, the people sometimes make that association directly, AI robotics. It's not necessarily tied, and there's something in common. It's that the fact that it's close to the human nature, and people see these as technologies that are a threat to humans because they look human. We talk about intelligence, we talk about robots, things that look like a human. But what we're seeing, obviously, is we get a lot of questions like this, maybe from the journalists, but the reality is that in the industry, people, again, they realize that the problem is not, they don't want to replace people, they really just want to augment the people and elevate the workforce they already have, whether it's with AI and robotics. So how can we do more by combining man and machine? And part of it is on the physical side, on the robotic side, and part of it is on the AI side, and it's going to really converge with the labor shortage to bring that massive adoption that Michael is talking about. That's going to happen in the next decade.
Perfect. We had one more question come in, and it is a funding question. And I don't know who necessarily to direct this to, so feel free to chime in. But the question is how people can access state-of-the-art robotics if they don't have venture funding or they don't have a large capital reserve to expend on that. And I know that we've seen a lot of leasing programs and things like that, but do you guys have any thoughts, anyone, on how
Yeah, so these leasing program is one option. There is a lot of great labs equipped with robotics. So there are some in your area in Arizona. There are some other example in Massachusetts. There's Mass Robotics, so where they have a pool of equipment where startups can go and develop technologies and prototype things before having to buy hardware. So it's probably more a local answer, but that's
Sure.
one area you can explore. So look at the research center and the nonprofit that target technology and startup development.
Awesome. And I'm trying not to weigh in personally answering these things, but we have seen a lot of leasing programs or various funding opportunities for companies. And typically anybody that is a distributor or a technical resource for these kinds of products knows who to call. So just feel free to reach out to us.
I would say additionally, something that I've been seeing is robotics as a service, where you actually lease the robots, and the company that you're leasing the robots from will help you with the setup and the support of the robot, and then you just pay a monthly or a bi-monthly fee. And then when you don't need the robots, you can either invest in the equipment fully at that point if you want to keep them, or you can change them out. And it's like leasing a car almost.
I have seen more of those programs coming out. It seems to be fairly recent in the last couple of years, but it's happening. Absolutely. Appreciate that. So we are just about out of time. Does anybody very quickly have anything they want to add before I let Carla wrap us up? Nothing? Okay. Well, thank you very much for your time. Sam, Michael, Tony, I really appreciate you joining us. And Carla, I'll leave it up with you.
Thank you so much, Brett, and thank you so much for moderating this morning's Tech Talk. And I'd also like to extend the appreciation and thanks to Michael, Tony, and Sam. We appreciate you taking the time to share your subject matter expertise. Very interesting topic, very prevalent. Thank you so much for joining us this morning. For more information about future events coming over the next few weeks, remember to visit our website at aztechcouncil.org. Thank you all so much. Have a wonderful day.
Thank you. Bye, everyone.